All right, hey guys. So today we're going to talk about exponential growth and exponential decay. So exponential growth occurs when a quantity exponentially increases over time. The formula is f of t equals a times 1 plus the rate to the power of t. The a is the initial amount, the r is the growth rate, and t represents time. So on this first example, so it says the original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. Okay, well, our initial amount on this is going to be $1,800. Our rate, you want to change the rate from percent to decimal format, so it turns into 0.07, and our time is 15. So if we plug that into our formula, that would be 1,800 times 1 plus 0.07 to the power of 15. Okay, and when you type that in, you should get $4,966.26. Okay, number 2 says in 2002 there were 972 students enrolled at Oakview High School. Since then, the number of students has increased by 1.5% each year. Write an exponential function to model the situation, then find the number of students enrolled in 2014. Okay, well, our initial amount, 972. Our rate, change that to a decimal, is 0.015. And the time, well, from 2002 to 2014 is 12 years. So it's 972 times 1 plus 0.015 to the power of 12. Okay, plug that in. Because we're talking about people, you want to round to the nearest whole number. So it's going to be around 1,162 students. Okay, all right, exponential decay. This is when it's decreasing over time. Same formula as up here, except now it's subtraction instead of addition. The a is still the initial amount, the r is the decay rate, and t is the time. Examples, an investment of $12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation, then find the value of the investment after 9 years. So the initial amount is $12,000, the rate is 0.04, and the time is 9. So this is 12,000 times 1 minus 0.04 to the power of 9. You plug that in, and you should get around $8,310.41. Okay. The next one, number 4, Mark bought a brand new car for $35,000 in 2008. If the car depreciates in value approximately 8% each year, write an exponential function to model the situation, then find the value of the car in 2015. Well, the initial amount is $35,000, the rate is 0.08, and the time is 7, because from 2008 to 2015, that's 7 years. So it's gonna plug it into the formula. That's gonna be 35,000 times 1 minus 0.08 to the power of 7. Okay, so it's going to be around $19,524.63. Okay, all right, flip over to the back side. We're going to talk about compound interest. Okay, this occurs when interest is calculated on both the principal amount and the accrued interest thus far. So the formula is the principal times 1 plus the rate divided by n, which n represents the number of times compounded, and then to the power of n times t. Okay, so p is the principal, which is the initial amount, r is the rate, n is the number of times compounded, and t is the time. So on the first one here, it says Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, well, our principal is $12,000. Our rate is 0.08. Our N, because it's compounded quarterly, is 4, and our T is 5. Okay, so this is going to be 12,000 times 1 plus, well, the rate is 0.08 divided by N, which is 4, and then to the power of 4 times 5. Okay, guys, make sure when you're typing this in the calculator that you're putting this in parentheses right here. Otherwise, it is not going to calculate correctly. And if you, whenever you type it in, if you want to do 4 times 5, or you can put 20, either way would work. Okay, you're going to end up getting $17,831.37 as your answer. Okay, number 6, Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5% interest rate. If the interest is compounded monthly, what will he have paid in total over the course of the loan? Okay, our principal is $25,000. Our rate is 0.045. Because it's talking about compounded monthly, our N is 12 and our time is 6 years. Okay, so this is going to be 25,000 times 1 plus 0.045 divided by 12, and it's to the power of 12 times 6. Okay, so same thing, you want to make sure you put that in parentheses. If you want to say to the power of 72, you can. So this is going to end up equaling $32,732.58. Okay, the next one, an investment account pays 3.9% interest compounded semi-annually. If $4,000 is invested in this account, what will the balance be after 12 years? Okay, the principal is $4,000. The rate is 0.039. Semi-annually is going to be 2, and the time is 12. So it's 4,000 times 1 plus 0.039 divided by 2 to the power of 2 times 12. Okay, and that is going to end up equaling $6,358.48. Okay, the next one, a savings account offers 0.8% interest compounded bi-monthly. If Bob deposited $300 into this account, how much interest will he earn after 10 years? Okay, so the principal is $300. The rate is 0.008. Because it says bi-monthly, well, there's 12 months in a year, and then bi-monthly, that's 2 times a month, so that's 24 times, and then for 10 years. So 300 times 1 plus 0.008 divided by 24 to the power of 24 times 10. And that is going to be $24.98. Okay. Well, I'm sorry. Hold on one second. Before I say that, you're actually going to end up getting $324.98 when you type that in. But then it says, how much interest will he earn? Well, the interest is the difference between the $324.98 and the original amount, okay, which is $24.98. That's where that comes from, okay. So when you type this in, you're actually going to get the $324.98, then take the difference between the two. Okay, 9, it says, suppose you invest $750 into an account that pays 3% interest compounded weekly. How much interest will he have earned after 20 years? Okay, so the principal is $750, the rate is 0.03. Compounded weekly, well, there's 52 weeks in a year, so it's 52, and the time is 20 years. Okay, so that's $750 times 1 plus 0.03 divided by 52 to the power of 52 times 20. Okay, so when you type that in, you end up getting 1366.35. And then to find the interest, you take the difference between that and the starting amount, which is $616.35. Okay. All right. So that is exponential growth, exponential decay, and compound interest.